All right, let's dive right in. Today, we're talking about one of the most important, but kind of invisible technologies that's shaping our world. It's called the knowledge graph. We're going to pull back the curtain and see how it's quietly revolutionizing, well, pretty much everything, from your search results to the most advanced AI. Let's get to it. So, it all starts with a problem I think we all feel, right? It's called the paradox of abundance. We are just drowning in information, but we're absolutely starving for wisdom. We have endless data points, but connecting them to find real, actual insight? Man, that's harder than ever. And this is the exact challenge that knowledge graphs were basically born to solve. To really get a handle on the solution, we first have to understand the journey of the problem itself. So let's take a quick trip through how the web evolved, because the story of information is really the story of trying to connect things more and more intelligently. Way back when, information was literally trapped in physical libraries. Then bam, Web 1.0 gives us the hyperlink, connecting whole documents. It was revolutionary, for sure, but computers couldn't understand the content inside those pages. Then came Web 2.0 with all its apps, but our data just got trapped all over again, this time inside Facebook or Google or whatever. You see the pattern, right? Each step forward solved one problem, but whoops, created a new kind of silo. And all that frustration led to this vision for Web 3.0, a web that could finally connect the individual facts themselves, not just the documents they were stuck. And what's so cool about this slide is how perfectly it just lays out that whole journey. We went from connecting physical documents to digital ones to apps, and now finally to the smallest, most powerful level, individual facts. Each stage was all about breaking down a barrier, moving from super slow human retrieval to true machine reasoning. And this is exactly the world that knowledge graphs were built for. So with that history in mind, let's meet the hero of our story. The knowledge graph isn't just some abstract theory. It's the real deal. It's the practical, working version of that semantic web dream. It's how we finally teach computers not just to read, but to understand. At its heart, a knowledge graph is actually beautifully simple. Instead of stuffing data into rigid tables with rows and columns, it organizes information just like our brains do, as a network of connected things and how they relate to each other. Think of it like a map of meaning. The first key piece of the puzzle is the node. Just think of nodes as the nouns in our data story. A node could be a person, like Tim Berners-Lee, or a company, like NASA, or even an idea, like artificial intelligence. They're the individual things we want to know about. But here's the thing. Nodes by themselves are just a list. The real magic, the secret sauce, comes from the edges. Edges are the verbs. They are the relationships that connect those nodes together. So Tim Berners-Lee invented the World Wide Web. NASA launched the James Webb Telescope. It's the edges that make the data come alive. And this right here, this is the whole point. When you put nodes and edges together, you don't just have data anymore. You have context. The system doesn't just see the word Paris. It understands that Paris is a city that is located in France, and that Paris is the capital of that country. This is that fundamental leap from just searching for keywords to actually understanding meaning. Okay, so this is a really elegant idea, but how does it actually make a difference in the real world? Well, this isn't just an academic toy. It's solving massive problems for businesses by creating what they call a semantic layer. This quote just nails it. Think of a big company's raw data like a library with thousands of books, all in different languages. The semantic layer, powered by a knowledge graph, is like a universal translator and a master librarian all rolled into one. It lets an AI read all those books and instantly understand how they all connect. And this is exactly why it's so critical. Most big companies have this last mile problem. I mean, they've got all the raw data in the world, but getting it over the finish line as a useful insight is a total nightmare. It's fragmented, it's been stripped of its business context, and it's locked away in tools that only experts can use. It's that paradox of abundance playing out in real time, and believe me, it cost them a fortune. See, the old way of doing things meant building these really brittle, hard-coded data pipelines. If you had a new business question, you might have to rebuild the entire thing from scratch. The knowledge graph approach is totally different. It's flexible. It can actually leave the data where it is and just create this virtual map of relationships on top of everything. This lets you adapt to new questions in hours, not months. It's a game changer. And the results of all that flexibility? It's huge. We're talking about companies seeing up to an 80% reduction in all that manual data wrangling that just eats up so much time and money. This frees up their smartest people to actually find insights, not just spend all day cleaning up data. But the story doesn't stop there, not even close. We're now getting into what I think is the most exciting chapter yet, where knowledge graphs are fueling the absolute cutting edge of generative AI through something called Graph RAG. Okay, the big idea here is that we're moving beyond just grabbing chunks of text for an AI to read. Instead, we're giving the AI a structured map of concepts so it can truly reason about a topic before it ever gives you an answer. So to really get this, you gotta compare the two approaches. The standard method is called RAG, Retrieval Augmented Generation. It basically works by finding snippets of text that look similar to your question. And it's good, but it often just pulls back these isolated, random fragments. GraphRag is so much smarter. It doesn't just grab a few sentences. It retrieves a whole neighborhood of connected facts, giving the AI this rich, structured context to really understand the topic. So here's a peek at how it works. First, your question finds a starting point in the graph. Then, the system starts exploring all the connections around that point, figuring out the most relevant relationships. Finally, it bundles up that entire structured map of context and hands it over to the large language model. The AI isn't just getting a sentence anymore, it's getting a whole syllabus on the topic. And does it actually work? Oh yeah, big time. Studies from some of the biggest tech firms have shown that for really complex questions, GraphRag can be up to 3 times more accurate than the old methods. That is a massive leap in performance. And maybe the most important thing of all is this. Because the answer is based on a clear, structured graph, you can trace its logic back. The system can actually show you why it reached a certain conclusion. This gives you explainability and auditability, which is absolutely critical if you want to use AI in places like finance or healthcare. So as we start to wrap this up, let's just zoom out for a second and think about the really profound implication of all this. This is so much more than just a new way to store data. This quote from the source material just perfectly captures the essence of this whole story. This huge transformation didn't happen with some big bang. It's been this quiet, steady revolution happening behind the scenes, structuring the world's information and building the foundation for real machine intelligence. And that leaves us with one final, pretty mind-bending thought. By connecting all the world's facts and their relationships, what we're really doing is building the semantic skeleton of a global collective intelligence. The question isn't if we'll do it anymore, it's what are we going to ask it once it's built?